right. So I would recommend you do this one the lazy way. Does anyone know how you do the lazy way? No. All right.
By accident.
If you don't, this what kind of error bound is this? What type of series is this for? Alternating series error bound. So it asks about some conditions that needed to be true for this error bound to work. Does anyone know those three conditions?
Alternating.
Decreasing in
magnitude. Limit as it approaches infinity. 1 over n squared equals 0.
Yeah, that's very accurate to this question. And just to be clear, the decreasing in magnitude, I know I should have changed some indexes, this bottom number here. As long as it's true at some point, you're good to go. If you know what I'm talking about, you know what I'm talking about. But if you don't worry about that. So those would be your three things. So I want you to start listing terms and figure out how many terms do you need to be within that. And I'm going to not be bad at fractions today. If you want to see me be bad at fractions, check out the video from my 8A class. Thought I lost my stylus. Would be bad. Literally use it all the time. All right, anyone know the first term? -1. What's the second term? All right. As I start going, I'm going to start asking, is it small enough yet? No. What do I need? What am I looking for as I'm listing these terms down? Something less than 1 over 65. All right, so -1/9. It's just perfect squares, right? Alternating in sign. So tell me when is small enough. Is this small enough? No. My fraction brain thought it was in second block, and they were all very mad at me, and then I was very mad with myself. All right, so now this one is small enough, right? This one, which number term is that? 1, 2, 3, 4, 5, 6, 7, 8. I could have just known 9 squared, but you know. The 9th term is less than 1 over 65. So what does that mean the answer to my question is? How many terms? 8. Because the next term up, my first truncated term, is the bound for how big my error can be. So my 8 terms is my answer. You could put some more notation on this. We called this R sub 8 is strictly less than that next term up. But really the bare minimum, I want to know those 3 conditions, which are a convergent alternating series. How many terms? Because this guy is less. Yep, you could also do 1 over 81 is less than 1 over 65 if you wanted to name it like that. Yeah. So the explanation would essentially be your alternating, decreasing in magnitude, and your limit of 0, because this only works if this is a convergent alternating series. Yeah, just wrote the sentence. Yeah. All right. So the other error-bound question asked you for, I made a boring one. What's his name? Alternating? Harmonic. Yeah. So this is in the Unit 8 folder on OneNote. If you are not a OneNoter and you want it, I can print it out and post it on Schoology as well.
How do you know if alternating harmonic
always converges? Because the terms are alternating, decrease in magnitude, and have a linear. What?
It's like -1 if n is equal to 2.
Yeah. If n is equal to 2, that's one specific term in an infinite series.
Yeah, but those one of the questions, which n value does converge with?
Oh, you would probably want that to remain alternating, so I wouldn't make it even, because then you're just getting like 1 all the time. All right. So the next one, this is the one with the 3 blanks. So I want the 4th partial sum the error bound, and the interval. I'm going to give you a couple minutes to think about that with your neighbors. Then I'll come back. If you want to leave this unsimplified, yep, so you had a calculator on the test. If you want to leave it unsimplified, that's cool. You know how to find the fourth partial sum at least? You're adding up your fourth error bound? So plug in 1. Plug in 3, plug in 4, and add all those together. Cool. Not set them up for an exciting. Look, this whole page. Should have put down something. You have it at a quarter. All right, do you agree with my partial sum? Did anyone get a number itself? What? 14 over 24, 7/12? Yeah? According to Matt, I'll trust him. He's got a calculator. All right, so what is our error bound? Yeah, so our error bound is the next truncated term, absolute value. So our fifth term here, which is 1/5. You could just write 1/5. That's perfectly fine. Yeah. Yeah. She's got it. So if I ask for the 99th partial sum, the error bound would be the 100th term. Wow. All right. Let's talk about the interval. Now, I don't necessarily want to give you a rounded one, but how do I find either side of this interval if I know that I have the partial sum and how far I could possibly be off? Add and subtract. So this would be 7/12 minus a fifth and 7/12 plus a fifth. I could simplify. There's technically a more clever way you can do this if you know which way is an overestimate or underestimate. I don't like to be clever. I like to be lazy. The best mathematics. All right, let's do, yes, ma'am. Not if you don't want to. You had a calculator though, so if you wanted to do some decimals, that might be nice. All right, let's do the question that no one knew what I was asking. Yeah. All right, I'm going to lead you through this. So this is a multiple choice question, and all it said was, what does this equal? What am I asking you for? That's a fancy way to say it. I'm asking you for the sum. Now, I'm asking you for a geometric because this one is geometric. So A over 1 minus R, you're saying? What's A? The first term. How do I find the first term in this one? Yeah, plug in n into the I. That would be our first term. So my answer is going to have an n in it. What's R in this case? 2/7. Cool. You could. I would just leave it like this. Then you're just going to simplify. All right. It was multiple choice, so probably going to want to.
Can we simplify it together?
Tell me what to do then. What's the bottom equal? What's the bottom equal to? How would you simplify it further? Oops, not like that. Sorry, this is an equal sign. Can I cancel those 7s?
No, the power. No, bro.
All right. Let's see. All right, I don't want to do this full question. There is, hi, thank you. Do you have the other one?
I think the alternative.
Okay. She smelled like cookies. Right? All right. So I'm kind of giving away what test I meant this to be, but most of you figured that part out. If the ends make you uncomfortable, you could totally make these X's. That's fine. So this was supposed to be integral test. I will tell you there is a way to do it without integral test. It's probably a little bit more elegant than doing it with integral test. It's fancy, so I won't. That's not that fancy, but it's kind of cool. So I'll let you figure that out if you want to. If you wanted to do integral test, what 3 things should you be telling me about that function before you get to positive, continuous, and decreasing? Those are true. Then how would you do the rest of this question? It's U sub. We need to do integral, improper integral notation. So I'd have to limit this guy out. And then what do you think U would be? That's x to the negative 2. So what's du? Which is happy, because that guy is that guy. So, what's this du? I saw a couple of people rewrite this one as like e to the 1 over x squared times 1 over x cubed dx. I thought that was smarter because this we could write as like negative 2 times 1 over x cubed dx. So that guy is that guy. Yeah. Because in this case, the derivative of that would be 3x squared. So it's not going to be super helpful. So I went for the function inside the other function, working with that exponent and kind of hoping that it was going to do what I wanted it to do. You could divide by negative 2 on both sides. Yeah, like negative 1/2. Yeah, I haven't substituted yet, so I would. Yeah, literally just pop out an AB. Haha. Yeah, she chose to go to the bathroom when I was teaching about how to do bounds. She was like, no. Okay. All right. Those were kind of the overall big problems that I saw with the test. Most of the other ones were like little notation things. You want to make sure you're really paying attention to your equal signs. So for example, I saw this on the quiz too. People setting things equal, like doing your nth term test. That's not what nth term looks like. Let's say you're doing like, not x. What's the problem with me saying this? Yeah, this equal sign is a major problem. Yeah, we should be doing a limit here, but you saying these things are equal is a major problem because now you're claiming this is the sum and you're about to tell me diverges by nth term, meaning I don't have a sum. So just really pay attention. This should be equal to the limit of our nth term. So this guy right here goes in that limit. So you just really want to pay attention to your notation. We're probably going to have a lot of yellow highlighting on this test if I had to predict. But those are kind of my overall comments. So you could plug in this function, then say equals negative 6 over 3 does not equal 0, diverges by infinity. Mm-mm. Tells you nothing. You have to do something else. For something that I would say for something that looks like this, I would probably compare to a P series. All right, so that's about all I want to do for like overall stuff. If you want to review some more, I am more than happy to talk with you in the morning. Are you just writing sleep over and over again? Are you writing Matthew? Oh, that's rude. All right. If you're looking for a review on ratio test, you're in luck. We're going to be using ratio test today to do something called interval of convergence. We're going to spend the rest of class doing 3 questions. And I don't know if we're going to get done. No, because you will not have enough room. So literally the first question we're going to be doing, this is what the page looks like. And I'm going to tell you, you probably need to write small. So you do not need a calculator. So I promise, the notes we're doing, the first question is going to be the hardest and it'll get easier after that. We'll probably take a break after that first question. So can you put your whiteboard stuff away? I'm going to pass out some notes for today. All that rhymes.
Oh, I got you guys already. Yes, I know. It's in like
All right.
it's in the like extended.
English Hall extended. All right, I got too much stuff out. All right, I need Oh, also some people were asking in my other class, I believe the Unit 8 test is the last big test on quarter 3. So, what? Water, yes. Interval of convergence. What? Yeah, so we'll do 9. We'll probably take before we go to spring break, but it'll go on 4th quarter because most of you guys being seniors, I need to fill in that a little bit. You don't just want one test. Oh, I need to like actually.
Oh, I did say there's a run in there.
All right, y'all ready? All right. I'm gonna start talking. So we need to talk a little bit about some vocab. So this whole front page, we're not going to really like write a whole lot on. So we're going to try to do the back of this first page. Again, this is what my notes look like. So you're going to see it's a long problem. This has a relatively good chance at being part of your Taylor series free response. Generally, that's a relatively low scoring problem, meaning people don't do very well on it. This, though, I think is very achievable, especially because those of you guys that did your ratio test on the Unit 8 test did a pretty good job with it. So this is something that is accessible. It's just long. It's long and methodical, but it's kind of the same problem every time. So let's talk about what we're actually doing. So Unit 8, the test you just took was about series of constants. So you were adding a bunch of numbers together. Now, what we saw with Taylor series last time, Taylor series are a type of power series, but we noticed that this kind of turned into x's and some powers. So instead of just having like numbers to powers, we had x's to powers. We talked about these x minus a number. What did we call like 5 last time? That's a very vague. Yeah, the center, where we kind of wrote our series around. Sorry, that was a really vague question. Thanks for reading my mind, whoever said that. So we were talking about where we wrote that series around, and we kind of saw those to powers. So these are all power series, and essentially what we're doing today with interval convergence is we're essentially trying to find a domain in like very, very basic language. We're trying to figure out what x's can I plug into a specific power series to get a series that does converge. But the idea of what x's will work in this case is kind of like finding a domain. It's going to be an aggressive way to find a domain, but that's kind of what we're looking for, is what x's will make a series that will converge. A lot of the stuff we did last unit will come back, but there are kind of 3 options. Now, we're going to focus before our break on this second option here. So for any power series, we have kind of 3 options. 1, we converge only at the center. It's kind of boring. We'll talk about that one last. We could have the series converge for all x. That's kind of like our all real numbers for domain. And then our last option, which is the most confusing and the most complex, is we could have what's called a radius of convergence. So this R is a number, and you can think of it as like how far out from the center can I go to get something that still converges. So we'll see why this kind of inequality comes up and all of that. It's going to spring out of ratio tests. So you kind of will have a very methodical way of finding this. So we're going to do that one first, and then we'll see the outer 2 examples after we hit our break. For radius of convergence, we can also be asked for this. It kind of is about halfway through our problem that we can find this number. We have kind of 3 options for this as well. One, the middle one that we're going to see, is we had a specific number. We might get like 3 is our radius of convergence. So we can start at our center and we can go 3 out to either side to get something that converges. If we converge only at our center, what do you think the radius is? If the radius is how far from our center we can go to converge? 0. That would be like you can't go anywhere. All right. Then if your series converges for everything, what do you think your radius would be there? Infinity. So I can go all the way out and I converge everywhere. Now, most of the time, if I'm asking about radius of convergence, I'm going to be concerned with the ones that are actually numbers, but these things can be true too. So again, the next problem we do, I promise, is the hardest one we're going to do. It is the version that you're probably most likely to get asked about. If you're concerned about practicing with it, I made you guys your second to last problem set ever. And there's 2 versions of this question. They are very, very similar. So once you kind of get the process down, it's not super complicated from there. So step number 1. Ratio test. You guys just did this. You know how to do this. The only thing that's scary is it's just kind of a big series. So we're just going to take it very methodically, step by step. We're going to get it. So that started with a limit, right? All right. I remember there were lots of fractions. How did I do the first fraction for ratio test? All right, I had to plug in n plus 1s everywhere there was an n. So this -1 to the n plus 1 is now going to become -1 to the n plus 2, because that's n plus 1 plus another 1. All right, x minus 5 to the n is going to become n plus 1. All right, what's the denominator going to look like? All right, that was a lot of mumbling, but I think this is what I heard. All right, can I close my absolute value bars now? I'm good?
No.
Aw. That was really well coordinated, guys. Reciprocal. There we go. Griffin's got the right words. Of the original one. Now, for those of you that don't like writing and like skipping steps, this is not the problem I would try to skip steps on. There are a lot of moving pieces in this problem, so I would encourage you to take them kind of one step at a time. Talking about a lot of pieces, I think there's two pieces in all of these fractions that I don't give one hoot about, and I would like to cross them out right now. The negative ones, let's talk about it. The negative ones, whatever way they cancel, here they're going to cancel into a singular negative one on the top. It doesn't matter. Why? We're absolute value barring the whole thing. So those, whatever way they cancel, are going to turn into a positive one. Ms. Hefty, do I have to write them there if I know that? Yes, we have to be interacting with the original series, the original nth term, so you have to write them, but let's get rid of them right away. All right. What? Are you guys telling me how to break down stuff? All right. So I think what I'm starting to hear is how I need to break down the rest of this. So same way with ratio tests when we were doing series of constants, we kind of want to focus on this stuff in the left-hand fraction and start breaking it down just the way I'm hearing Nina Ingerman break it down. So x minus 5 to the n plus 1. I'm going to do x minus 5 to the n. X minus 5. You could put a 1 there if you want. I'm not going to because I don't want to. All right, on the bottom, can I do anything to the n plus 1? No, please stop doing that. And then 2 to the n plus 1, I'm going to do 2 to the n times 2. Yeah, not really. There are some cases when we have like factorials in both of them, but generally I'm trying to match up whatever I broke down in the left-hand side with something in the right. All right, now the most fun time. Cancel time. What goes away? All right, I heard 2 to the n first, and then Nina and Rashad are saying x minus 5 to the n. All right, question. Can I cancel those? No, don't do that anymore. You're better than that. You are better than that. Matt, what did there was a calculus teacher who used to be here. Does anyone know Mr. Maines at this point?
Oh, my brother had a.
Nice. Oh, he used to say terms are trouble. So if they're being added, you can't cancel them. Factors are friends, I think. So if they're multiplied. All right, so I'm going to rewrite this. I'm going to rewrite this kind of weird, though. So we have not dealt with this x minus 5 before, so I'm just going to like separate him off to the side. I'll be like, I'm going to deal with you separately. And then I'm going to put everything else in one fraction over here. Because the stuff on the right I've dealt with before in ratio tests. The stuff on the left, the x minus 5, I have not. I need to sit down.
Are you okay?
It's a long problem, man. You get halfway through and you're like, wow. Almost.
Dang, I've been writing since fall.
Oh, sorry. All right. See, you guys are good at this already. All right, now we have to pay attention to this limit. So you guys are not named Zacharios. You are not taking multivariable calculus. So we have an issue here. We have n's and x's. In this question, only one of those variables is acting like an actual variable in this question. Does anyone know which one's acting like a variable? N, and that's because that's what's in the limit. So when I think about this term right here, that's really acting like a constant. So the limit of that constant is just going to be itself. So that part is going to stay in absolute value bars in my answer. Now let's look at the rest of this guy. Where is this fraction trending towards as n approaches infinity? All right, do you guys agree with Rashad? 1/2? All right, we got same power, top and bottom. We're doing ratio coefficients. Instead of writing 1/2, I'm going to write divided by 2 here. So this is the answer to my limit, and this is a little bit weird. We have not gotten an answer like this to ratio tests before. We're used to getting either a number or infinity, and that's pretty much it. So I'd like to remember what do we normally do with the thing we get out of ratio test? I remember us comparing it to something. Greater or less than 1. Which one of those two options was the one that converged? Less. So I would like to claim, and here is kind of our halfway point. That looks terrible. Our series, do you ever just write a letter and you're like, wow, I hate my handwriting? So our series converges when this fraction is less than 1. All right, so now we're going to do a bunch of work to figure out some more detailed stuff. So we have kind of the overview. Now, one way to find the radius of convergence, I'm going to scroll back up for a second. Notice that the radius of convergence was the number that was here when I kind of isolated the x minus the center in absolute value bars. So the first thing I'm going to do here is get rid of the 2 by multiplying. And this is going to be our radius of convergence. So if I just asked you for the radius, I would be done. I did not. So we're going to start by making an interval for ourselves to work with, because what we're finding is called the interval of convergence. Now, the easiest way to do this is actually to think it out instead of doing algebra. What is the center of this series? 5, and our radius is 2. So if we're thinking 2 to the left of 5, 5 minus 2 is 3. If we're thinking 2 to the right of 5, 7. All right, technically you can do this with algebra too. If you don't care, just close your ears for about 2 seconds. If you're solving this absolute value guy, you can set this between -2 and 2 and then add 5 to all 3 sides. If you don't care, just don't worry about it. But you can solve that algebraically. All right, so we have an interval. The last part of this is going to feel really, really silly. Because we're going to do a pretty big amount of work to learn 2 very small things. So we now know that any x we plug in between 3 and 7 will create a convergent series. We have 2 questions. What about 3? And what about 7? So we have to literally do a ton of work, about half a page's worth, to figure out, does this series converge at x equals 3, and does this series converge at x equals 7? So we have to test those 2 endpoints separately. Does anyone care which one we do first? Good, that one's harder. You guys don't like doing the harder parts first?
Yeah, no, I do.
Yeah, let's get it out of the way. All right, so we're going to start with x equals 3. Now, how do we test this endpoint? Again, this is going to be kind of the same thing every time. We're going to take that x value and we're going to scroll all the way back up to our original series. We're going to plug that x equals 3 into that series, and then we're back in unit 8. If that x is gone, that's a series of constants, and I've got a whole tool belt of what I can use to say if this converges or diverges. So my series is still going to go from 1 to infinity. The -1 to the n plus 1 from the original series is going to stay the same. But now I am using x equals 3. So instead of x minus 5 to the n, I'm doing 3 minus 5 to the n. 3 minus 5 is -2. Thank you. All right. And then on the bottom, we've got n times 2 to the n. Wow, this looks horrific. What? How is that going to tell me if it converges? That would tell me the first term. All right, I could do the ratio test again, but that feels a little extra. Let's just try to simplify this guy a lot. Oh, yeah. Are you ready? You could do alternating series tests. I'm just going to show you how to break it down. So I'm going to break this down into something else. You tell me if it's legal. Hopefully you agree with me. This one does kind of cool stuff. So just Don't whine about simplifying it yet. All right. Is this thing equal? Are the two blue circles equal to each other? Are you convinced yet? It is true. I just want you to be convinced. Negative 1 to the 6 times 2 to the 6.
Oh. They just basically expanded it?
Yeah, because 3 times 2. Yeah, that's true. You can't do it if it's add. That's bad. But you can do it if it's multiply. All right. So this guy is true. Why would I want to do that? Yeah, everyone see these 2 to the ends? Let's get these out of here. Get out of here. So the reason I'm doing that is a lot of these endpoints are going to simplify into a relatively simple looking function. So I'd like to point out that in the denominator, I now just have n. There were a couple of functions that just had n in the denominator. Can you name either of them? Harmonic or alternating harmonic. So I need to figure out with these negative 1 to the n stuff, is this alternating or is this not? Now, what would this power be if I had negative 1 to the n plus 1 times negative 1 to the n? How do I get those powers together if they're the same base? I'm going to add them. So I have n plus 1 plus n. So I think that's 2n plus 1. All right. For about the next 30 seconds, I need you to figure out, does this alternate or does this not alternate while I take attendance? I'm going to say, you guys are lucky that I don't have you first block because I used to get yelled at for taking attendance late all the time. Dude, I haven't even taken attendance for my last class yet. What?
The negative 1 to the 2n plus 1 is not always going to be
Is it alternating?
Yes, it does it alternate.
no.
Mm.
Oh,
Yeah.
okay.
When Nina thinks she found a mistake and realizes she's just answering the question. All right, someone was missing today. Who's missing today? Is everyone here? Oh, bro, she's never here. Was she here this morning? She's skipping?
Oh, yeah.
I'm saying, you owe me something, don't you? Oh, I have a list. Y'all, I'm getting tired of people asking me if they can turn in their outreach forms late. I will make that decision. Why? I would have told you to contact the outreach team. Why do y'all wait until the last minute to do things? That's why you got to become that person. Yeah, no one wants to talk at faculty meetings. I just became that person. It's not fun.
Wait.
All right. Does this alternate? No, because what's true? I think I heard it at this front table. What's true about that power if I plug in 1, 2, 3, 4, 5? It's always going to be odd. That's actually a really good way to define odd numbers is 2n plus 1 or 2n minus 1. So since this is always odd, this top function, top part, is only going to equal -1. So what type of series is this guy? This is harmonic, so it diverges. All right, you want to know what we just learned? We don't add the or equal to here. Wow. So we're trying to decide, do we include 3 in our interval or do we not include? Because we learned that it diverges. If I plug in x equals 3, I've learned that I do not include 3. I just like this part of the question because it feels like you're not doing a lot. Yep. Now we do exactly the same thing for 7. The nice part is usually one of the 2 endpoints is going to be quite a bit easier, and I am going to tell you it's 7 in this case. So I'm going to now do the same thing. I'm doing -1 to the n plus 1, but now I'm going to plug in 7 minus 5 to the n. So 7 minus 5 is 2 to the n. Does everyone see why this is going to be a little bit easier? Yeah. I don't have to do any of that creepy power stuff to get these 2 to the n's to cancel. They're just going to do that right away. I mean, technically, no. I'm just being really thorough since I'm the one making the official notes. What's his name? This one definitely alternates, right? So this is the alternating harmonic. So what does that do? Converges. So let's see what I learned. I learned. Boop. No. All right, so let's do our final answer. And then I'm going to throw some follow-up questions at you before we kind of take a solid break here. So if you're writing in regular notation or like set notation, I guess you could say, we would write 3 is less than x is less than or equal to 7. So notice we're including everything between 3 and 7 and also including the endpoint 7. If you're more of an interval notation fan, you would want a soft bracket 3 and hard bracket 7. That's the worst hard bracket I've ever drawn. Either one of those is fine. So some follow-up questions. Give me a number that I could plug in for x where the series would definitely converge. 4 works. Give me another one. 5 definitely works. That's the center. 7. All right. What about 11 halves? Fractions. They're hard. That's 5.5. So yeah. Give me an example of something that would not converge. 396. 3. Google. 0. Any negative numbers? 2. All right. So the idea again is this is the stuff where I can plug it in and it would converge. So before we take our break, I would like you, as an acting challenge, choose a mood. That mood could be anger, frustration, happiness, depression, whatever works the best for you. And I would like you to use that mood to walk your neighbor through the steps of the problem. You have 30 seconds to do so. All right. Thank you all for getting very into that. Saw some moves around the room. Yeah.
We got 3 of 7.
Yeah.
2 to the right of 5.
Mhm.
Is that because the radius of convergence was 2?
Exactly. So this is center minus the radius,
Okay.
and this is center plus. Perfect. Yeah. Were there any other sticking points? Any other confusion points? You know.
Finding the radius of history. Why didn't you add 5 and be able to
I want to kind of isolate the x minus whatever inside the absolute value bar. So isolate those absolute value bars, and then you're done. Because you actually can't add that 5 with the absolute value bars there. You're kind of stuck with that. Mhm. Yes. Yep, because your ratio test always has absolute value bars. For these last ones, actually, for the endpoints, is that what you're talking about?
Well, like, you know, you do ratio tests.
Mhm. Not really. There are some you could use geometric on, but those are a little bit weirder. Probably not. To be quite honest, a lot of these have factorials in them, so then ratio test is the test you're going to want to use. Theoretically, if the test works, I guess you could, but this is the one that's going to work most of the time. All right, one comment before we go to break. Hello. Just one comment before we go to break, because I didn't really mention it, but I just wanted to bring it up one more time. Now, usually these endpoints are not going to be something crazy. So when you're talking about these endpoints, usually things like harmonic, geometric, alternating harmonic, T-series, usually those are the ones you're going to see towards the end. So it's not like you're going to have to pull out an integral test or like a limit comparison for the end. Usually these are going to be much easier series to work with. It's not going to be like a full-on thing. So when we come back from break, again, we saw one of the versions of this question. So as we finish up today, I'd like to show you the other ones. Again, those options are the series converges everywhere or the series converges only at the center. You'll notice there's not an option for like the series diverges everywhere. So we'll talk about why something always has to converge at the center. So let's take a solid 5-minute break today. And I promise the questions that when we come back will be easier. Yeah, what time does class end today?
I think it's 44.
45?
45. I might not be here for Wednesday.
Okay.
My mom put a doctor appointment.
Okay.
Orthodontist appointment, sorry. But I don't know what time I'll be back.
So we'll do round 2 at the beginning of class. So if you missed that, you'll think of to find time outside of class. And then whatever.
Sounds good.
Yep. Noah. I've been told 45. I was just gonna check that. There's so much I want to tell you guys. I don't know. I think it's silly too. Did anyone actually log into a club?
I did not.
That'll schedule. Club J. 2:44. That makes me sad. I want more time with all of you lovely humans. 2:44.
44?
I know. I want to do 2 more questions.
That's crazy.
2 more questions shouldn't take me 20 minutes, you know?
The last one took you.
It took me like a hot second to do. But imagine that was part of your free response. And you were just like, I got it. No. I did a quick peek through. I didn't like officially highlight them. This test takes me a really long time to highlight. So not gonna lie, I was procrastinating a little bit. Yeah. You didn't want to do it right now?
Oh, yeah.
You have 7%. I answered most of the
I saw it. You were actually working on it during your test. I liked that. Yeah.
I don't know if they're right.
Yeah. This next test. Taylor Series is a hard test.
Is Taylor Series This year?
No, it just gets a little weird, and like, especially with when we write the Taylor series, we often write them not in Sigma notation, so it becomes a lot of writing, which a lot of people get grumpy at. No, we're gonna have a lot of algebra in the next couple of days. It's not terrible.
Is it like trigonometry algebra?
No, that's a good question. 2 minutes. No, they're just long problems. I'm just hoping one year someone wrote me a poem on this test, and that's about the extent that they did. Yeah, it was about Taylor series. And they did write it in the bonus question. Yeah, it was actually really good, but I couldn't because there was no knowledge. It was more so complaining about Taylor series than like knowledge of it. I tried. I saved it somewhere.
It's actually really funny.
He thought it was. I honestly don't remember his last name, and I don't want to throw him under the bus. It was a while ago, and the rest of his class was very good at math. It was Ryan Thomas's class. Who else would you know in there? Oh, Elena's older brother was in that class. Ryan was in that. When did he graduate? What? From here. 2018. There's a kid that wrote me a poem on this Taylor series test instead of doing it. He was in that class. And, yeah.
About Taylor series?
Loosely. It was a good poem.
Oh,
Let's see if I can find it. Yeah, I do have it.
It like sounds
It doesn't make any sense though. Yeah. I might have to do a dramatic reading later. I haven't read it in a while. I don't know if I would give a good one. Maybe I'll put it as the intro to our test so you can read it and get inspired. Yeah.
All right. Get yourselves back in order. We got 2 questions. All right, so this one right here.
Fun fact. You guys want to know something that's true about this question? If you're curious about Taylor series, that's a true statement. We will next class. No, because we want to know the interval of convergence. So I want to know for what x values is that true. So let's start with our ratio test. I'm going to do the limit as n approaches infinity. Now, adding 1 to this power is a little bit creepy, so I'm going to do it in a couple of steps. -1 to the n plus 1 is fine, but let's talk about this 2 times n. I don't just get to do x to the 2 words. I use parentheses. So I got to do it like this. This 2 essentially has to get distributed in. I got to be really, really careful. So you can't just like do 2n plus 1 plus 1. You got to do 2n plus 1 plus 1. That made no sense on the video. Cool.
No. The way you grouped it.
The way I grouped it with my pauses. All right. So got to make sure I'm doing that 2 distributed in. Now I'm going to reciprocal this bad boy. Again, these questions, and I think this is a lot with Taylor series, the chapter in general. The questions look a lot scarier than they actually are. So just let yourself write down things and kind of segment your decisions into less scary ones than the whole problem. I'm going to. So if you had wanted to simplify in one step, you certainly could. I just wanted to be really explicit about what's happening with that 2n plus 1 because it happens to be a mistake on a lot of different papers. As I'm going to write the next step, I'm going to leave something off. Anyone know what it is? Get out of here. All right. I almost feel like, you know how pet birds like repeat back whatever you say? Sometimes y'all are like my pet birds. Parrots. That's the word I was looking for.
I'm your bird. I'm your bird. You're a bird, I'm a bird.
Oh, there we go. All right, 2n. So let's see. When I distribute in, I got 2n plus 2 plus another 1. So I think I have 2n plus 3. Then 2n plus 3 factorial, since I did the same thing on the bottom. Yes, to the whispers in the back. You are exactly correct. My ears actually worked. They were complaining about a part of the problem that's about to happen.
Wait, can we cancel that?
No, because that's not how factorials work. All right, so let's break some stuff down. So how would you guys break down the exponent here for x to the 2n plus 3? All right, so we could do x to the 2n times x cubed. I'd like to offer another option.
Can you do x to 2n plus 1 and then 2?
That's exactly what I would do. So what Hannah is saying is, why don't we do it like this? That would be super advantageous because look what we have in the bottom right of our set of fractions. So I certainly could do 2n and 3 as my two options, but this is going to let me cancel straight away and already be done. Actually, I'm not going to write that yet because some people were noticing a little bit of an obnoxious thing about the denominator here. When I break down this factorial, I have to start counting down. So I have 2n plus 3. What would the next one be? Now, do I want to stop here? No, because I have 2n plus 1 factorial. So I'm going to do 2n plus 1 and then throw my factorial on there. So I have to keep counting down until I get a match. 2n plus 1 factorial on the top, and then x to the 2n plus 1 on the bottom. So again, you just got to be willing to write, take it a little bit slow. We'll be okay. You're welcome. Because you're counting down by 1 every time. So like if I were doing factorial, I've got like 8 factorial would be like 8 times 7 times 6 times 5. So we're just subtracting 1. So since we don't know how,
you get rid of all the constants.
Yeah. Then you would just even start subtracting. So like after this, I would do 2n, 2n minus 1, 2n minus 2, 2n minus 3. So the n's always going to be there.
So factorials only deal with adding or subtracting.
For the next term down, yeah.
Provide anything.
All right, cancel time. What can go away? 2n plus 1 factorial. Again, those factorials have to match, and so I have to have the exclamation point on both of them, and they have to be the same thing inside the parentheses. All right, x to the 2n plus 1. Everything else I think has to stay. Now, I'm writing a lot of steps. You might have been able to do this in the step before, but writing's not that bad. All right, let's look at this. I'm remembering I am not in multivariable calculus, so only one of these letters is an actual variable. Which letter is a variable with respect to this limit? N. So I have x's only on the top, n's only on the bottom. Where does this limit trend towards? All right, there are two options. One is 0 and one is infinity. Which one's right? Why is that right? All right, x squared is a constant, so the only thing growing is my denominator. So this is going to 0. Now notice, this is very different than the last question where we had x's left over after the limit. Here we have a number, which we're supposed to compare to the number 1. How does it compare? Less than 1. What did that normally mean? this meant that it converged. So what I'm kind of learning here is that this is going to converge no matter what I put in for x. I could put in 5, I could put in pi, I could put in e, I could put in anything I want. This series, just to write some notes, is going to converge no matter what x is. How fantastic. No. Yes. I like to use unit 10 at the end because we kind of go back to integrating and taking derivatives. So it's a good review because this doesn't feel like integrating and taking derivatives. All right, so what is my interval if every value of x works? That's a good radius. What's my interval? Yeah, it's effectively your all real numbers, so negative infinity up to infinity. If you like set notation, or you could use some sweet interval notation. I love when my computer freezes. It's my favorite thing. I don't know. You know, maybe it's my fault. Maybe I'm asking it to do too much.
Yeah.
So remember that your radius is telling you, sorry, this is probably going to go away in a second, but think your radius is telling you how far. Yeah, Jillian. Technically you could. Usually we're going to see these written as an interval, so that's why I'm using either the set or the interval notation. Let's just go with that because that's the only thing I've seen on the answer keys. It would probably, honestly, this one would probably be a multiple choice, and they'd probably write something to the effect of like, this series converges for all x. I'll look at it. I'll try to figure it out. Michaela, what's up? Let's find out. What a great transition. Speaking of, does anyone remember the center for this one, by the way? Does anyone think they know what the center for this series is? 0, because I don't see an x minus something. Sine of x, because it is sine of x. This one? It would be hard. I don't know if you can plug in that. I'll try at the end of class. I would love to do this question, though. All right, ready? Limit n approaches infinity. Now, this one's not a fraction, so instead of multiplying by the reciprocal, I'm just going to divide. So I'm going to have the n plus 1th term just divided by the nth term. Oh, I really got your attention there. Love when all of a sudden people are listening. So you can hear my songs. All right. How would you break up the numerator? All right. I'm gonna do what I think the murmurs said. Murmurs, did I get it right?
Why is there still factorial? That's the lowest you can go.
Because I could do n minus 1, n minus 2. It goes all the way down to 1, technically, so I'm collecting everything that...
Oh, so you don't know if n is...
Mm-hmm. Because n's getting really, really big, right? So... All right, cancel time. Boop, boop. Boop, boop. All right, this limit is not looking great for converging because it doesn't have a denominator. All right. Technically, we don't know what x minus 6 is doing, but since we only have n's in a numerator and we're absolute value barring this, I do know exactly where this limit goes. Where does it go? Infinity. Why do I care? Let's go with it's greater than 1. So this diverges, but that was not an option for diverging everywhere. Does anyone remember what this option was? Converges only where? Converges only at the center. So I want to show you why this is going to converge at the center. by testing the center of this series. What is the center of this series? 6. All right, the way we found that, see this x minus 6, always x minus whatever our center is to that power. So I'm going to plug in 6. Generally, if I don't know what's happening, plugging in something helps. 6 minus 6 to the n. What is 6 minus 6? What? Okay, so I'm going to write it like that. So what's the first term of this series? We've got 1 factorial times 0 to the first. What's 0 to the first power? Times anything in. All right, what's 0 to the second power? Times anything is. What's the third term? What's the fourth term? Can you add all of those together and get something that is a real number? Yeah. And that's going to happen every time you work with something that is the center of your series. Now, I will say if this had been n equals 0 at the, well, it wouldn't. You can get some weird things where you might have like 1 first term. So it's not necessarily the sum is always 0. But what I will tell you is that always is going to converge. So let's talk about how we would write our answers. The interval of convergence. This one's actually fun. If you like fun notation things for weird things, what is the only place this series converges? Which in this case is? The center is 6. Now, I had a few students a couple years ago say, well, what if I wanted to write that in interval notation? So here's your fun facts for the day. If you have a single point that you would like to write in interval notation, you can write it one of 2 ways, 6 comma 6 or 6. Notation. I like notation. Radius. How far can I go from the center and get something that converges? Cool. All right. So we've missed a couple things in both of our last couple of notes. We'll see if we can pick them up as we go. This is going to have us play with some of our intervals and our radiuses. Next class, we're also definitely going to pick up the notes check on this. This is one thing where if I don't do the notes check on this section, I am not doing my job right. Let's see. We have about 2 minutes to go in class. What's happening next class? Round 2. Round 2. It's going to happen when we walk in the door, 20 minutes per use. I did make the problem set already. I'm just going to drop it in the middle of the room. If anyone wants to grab a problem set already, you're more than welcome. If you want to just focus on round 2, that's totally fine as well. Thank you guys for your hard work today, and I will see you on Wednesday. Make sure if you have to turn in your outreach form, you turn in your outreach form. Juniors are figuring out what the heck you want to do on the
Are we allowed to do that? Yeah. If you didn't, I don't have to find a person to open the door. Just ask the freshman. They get in trouble, they'll be like,
Yeah,
I didn't know
like,
anything. They won't get in trouble. I just want to
do that project.
I listen to you. Photograph here. Yeah. Oh, wait. Is this the fake? I really want to go. Really want. Let's do it Friday. Yeah, let's do Friday. I mean, I still want to get home.
Bye, Stephanie. Bye. Thank you. Yeah. It's Braden. Braden Souza.
He's a troublemaker.
I was happy. Thank you.
I have a question.
Yeah.
So for New Year's outreach, I can do my 50 hours. Am I like do I still have to?
I would just talk to the outreach team about that. I know the schedule form there's probably some qualifications. I don't remember because we had weird rules last year, so I would check with them about that. Water. That I just swallowed wrong. I can take it for you. Thank you so much. Absolutely. Hi. Swallowed my water and swallowed my water from.